Hello viewers, so welcome to my channel. I am Hasham. So far I have completed 11 problems on t-test. In this video I am going to start with 12th problem. So my suggestion, if you have not watched the earlier videos, I suggest you to go to the playlist of my channel. Select the subject Statistics for Management. Select the videos problems on t-test. If you join right now, you may not be able to understand. You have to keep a rhythm of watching one video, then next one, then next one. Then only you can be able to get the complete command. And particularly in this t-test, we have varied type of problems. Different type of problems we have in this t-test. So now I'm going to start the 12th problem. But before that, I expect my viewers to have a printout of the problems which I have given in the link under my description. So always keep ready the problems. Take a screenshot of the problems, the notes which I have written. Then I'll explain all the points of the problems. Come on, see the 12th one. A group of 5 patients treated with medicine A weigh 42, 39, 48, 60 and 41 kilograms. Second group of 7 patients from the same hospital treated with medicine B weigh 38, 42, 56, 64, 68, 69, 62 kilogram. Do you agree with the claim that medicine B increases the weight significantly? Use the level of significance of 5%. Two medicines are there, medicine A and medicine B, for increasing the weight. For increasing the weight. We want to test whether B medicine is increasing the weight significantly compared to A medicine. So we have administered A medicine to 5 patients. And how much is the increase in weight given? And we have administered B medicine to 7 patients. And we have noted down the increase in weight. Now by using 2 samples, one sample size 5, the second sample size 7. The values of first 5 samples given and the values of second 7 samples are given. So we'll make the null hypothesis no significant difference between medicine A and medicine B because they are increasing the weight equally. Alternative hypothesis, mu1 is less than mu2. That means medicine B is increasing the weight significantly compared to medicine A. That is the alternative hypothesis. But first of all, the sample mean and sample standard deviation not given. So we have to find out the sample mean and the standard deviation. See, calculation of sample mean and standard deviation. First of all, medicine A and here medicine B. So 3 columns I have prepared for medicine A and 3 columns for medicine B. First of all, X1. X1 is the increase in weight by medicine A. That is given. 42, 39, 48, 60, 41. These are the increase in weight given in the problem. The total is 230. So we can easily calculate the mean value. X bar is equal to summation X by N. 230 by 5, 46. So 46 is X bar. Now we calculate D. D is equal to X minus X bar. X bar 1. X1 minus X bar 1. So X1 42. 42 minus 46 minus 4. 39 minus 46 minus 7. 48 minus 46 2. 60 minus 46 14. 41 minus 46 minus 5. Square it. 4 4 is a 16. 7 7 49. 2 2 is a 4. 14 into 14 196. 5 5 is a 21. Take the total summation D square 290. Now we can apply the formula for standard deviation. Summation D square by N under root. So 290 divided by 5 root will get 7.616. This is the standard deviation of medicine A. So we got the mean value and standard deviation of medicine A. Similarly, we have to calculate for medicine B. The increase in weight is denoted as X2. So whatever is the increase in weight, I have taken. The total is 399. The mean, first of all, mean X bar is equal to summation X by N. 399 divided by 7 values. So it comes to 57. The mean of medicine B is 57. Now X2 minus 57. 38 minus 57, 19. 42 minus 57 minus 15. 56 minus 57 minus 1. Like this. Now square it. 19 into 19, 361. 15 into 15, 225. Like this square. Summation d square, 926. Now we apply standard deviation. Summation d square by n. So 926 divided by 7, you will get 11.502. So we have calculated the mean and standard deviation of medicine A and medicine B. Now in a nutshell, I can write down n1 is equal to 5, n2 is equal to 7. 5 values in sample 1, 7 values in sample 2. X bar 1 here 46, X bar 2 57. S1 standard deviation of first sample 7.616, standard deviation of second sample 11.502. Now we can apply the steps of hypothesis testing. First step, null. Null means no difference. Mu1 is equal to mu2. No significant difference in medicine A and medicine B regarding the increase in weight. Both medicines are equally increasing the weight. Null. Alternative hypothesis, mu1 is less than mu2. Why I have taken this one? In the problem it is asking whether B medicine increases the weight significantly compared to A medicine. That means by administering B medicine, the weight is increasing more. B medicine is more effective in increasing the weight, whereas A medicine is not so effective. So mu1 is less than mu2. Left tail test. Medicine B increases the weight significantly than medicine A. Medicine A will increase at lesser rate and medicine B will increase at a higher rate. That means mu2 is more than mu1 or mu1 is less than mu2. Level of significance alpha 0.05 given in the problem. Degree of freedom n1 plus n2 minus 2. So 5 plus 7 minus 2, 10. Test statistic. Already in the previous problems also we have applied the formula. X bar 1 minus x bar 2 divided by s square into 1 by n1 plus 1 by n2 under root. So s square formula, n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. I am not stressing here because already this type of problems we have done in the previous videos. Previous problems I have applied this problem. So n1 is 5. S1 is 7.616 square plus N2 is 7, S2 is 11.502, all these values are here, square. Now if you simplify, you will get S square 121.61, this is S square. Now T is equal to X bar 1 minus X bar 2, 46 minus 57. Divide by S square 121.61 divided by 1 by 5 plus 1 by 7. If you simplify, you get T is equal to minus 0.26. Computed value of T. Now we compare with the critical value. The table value of T at 5% level for V is equal to 10. Here V is equal to 10. For left tail test, single tail, the one column before you have to refer, is minus 1.81. So this is the T table. I have provided the PDF of this T table in the description. So take a printout and keep it ready. So 10 degree of freedom. In the row 10 degree of freedom at 5% level, for two tail test it is 2.23. For two tail it is 2.23. For one tail, one column before, that is 1.81. So 1.81 minus 1 point. Minus I am taking because it's a left tail test. Left tail test minus right tail test plus. Decision, the computed value of T minus 0.26. is greater. Minus 0.26 is greater than the critical value minus 1.81. So it falls in acceptance region. The null hypothesis is accepted. There is no significant difference in medicine A and medicine B. Both have equal effect in increasing the weight. What it is asking is medicine B is increasing significantly. No, both are same. There is no significant difference in medicine A and B regarding increase in weight. That's it. This is the end of problem number 12. Now you see problem number 16. The remaining problems I will do it in the next video. Now 16th problem you see. A drug manufacturer has installed a machine which fills automatically 5 grams of drug in each vial. The drug is being filled in vials. So a machine is there which fills 5 grams of drug in each vial. That is the setting of the machine. A random sample of 10 vials was taken and it was found to obtain 5.02 gram on an average in a vial. In order to test whether the machine is filling the drug properly or not, we have taken a sample of 10 vials. So the average of this sample of 10 vials is 5.02. So actually it should fill only 5 grams, but it is filling 5.02 grams. And the standard deviation of sample is 0.002 gram. Test at 5% level of significance if the adjustment of the machine is in order. Now we have to find out whether the machine is working properly or not. So null hypothesis, mu is equal to 5 gram. We assume that machine is filling properly. Every file is having 5 gram only. No significant difference. Alternative hypothesis, the machine is not working properly. The machine is not filling 5 grams of drug in every file. Some files it is filling more, some files it is filling less. Two-tailed test. So here mu is equal to 5 gram. The population mean is 5 gram. Sample mean, x bar is the sample mean 5.02. S sample standard deviation 0.002. N sample size 10. Alpha 0.05. Now null hypothesis mu is equal to 5 gram. Whatever is given we assume same. No significant difference, the machine is working properly. No significance. Alternative hypothesis mu not equal to 5. That means the machine is not working properly. It is not filling 5 grams of drug in each vial. Two-tailed test. The machine is not working properly. Level of significance alpha 0.05 given. Degree of freedom v is equal to n minus 1, 10 minus 1, 9. Test statistic t is equal to x bar minus mu divided by s by root n. This is the formula we have applied in the starting problems also. First and second problem you see. We are comparing the sample mean with the population mean. Now S. How to find out S? N divided by n minus 1 into S1 square. S square. Small s square. Small s is the sample mean. 0.002 square into 10 divided by 9 under root. So we are getting S is equal to 0.0021. Now we substitute T is equal to X bar. X bar is 5.02. So 5.02 minus 5 divided by 0.0021 divided by root 10. So finally you will get T is equal to 30.12. This is the computed value of T. Now critical region. Table value of T at 5% level for V is equal to 9 for two-tailed test is plus or minus 2.26. If you refer the table, you will get 2.26. Plus or minus because it is a two-tailed test. We compare with the positive value because we are having positive. Computed value of T 30.12 is much greater than the table value 2.2. So it falls in rejection region. The computed value is very, very high. So it falls in rejection region. So we reject the null hypothesis. Null hypothesis we reject. Alternative hypothesis we accept. What is the alternative? The machine is not working properly. So the machine is not working properly. That's it. This is the end of 16th problem. Now you see the 18th one. 18th one. A certain medicine given to 9 patients resulted in the following increase of blood pressure. One medicine is given, medicine is there. The medicine was given to 9 patients. After giving the medicine to 9 patients, how much is the increase in blood pressure, BP? So first patient 8 points increased. Second patient 3 points increased. Third patient 1 point decreased. These are the increase and decrease in blood pressure after giving the medicine. Can it be concluded that the medicine will in general be accompanied by increase in blood pressure? We want to prove whether administering of medicine will increase the blood pressure. That means before administering the drug, the blood pressure was less. After giving the drug, after giving the medicine, the blood pressure is increasing. That's what we want to prove. Here, null hypothesis mu1 is equal to mu2. There is no increase in BP. That means before giving the medicine and after giving the medicine, the blood pressure is remaining same, no change. So mu1 is equal to mu2. And alternative hypothesis, mu1 is less then mu2. Because we want to prove that after giving the medicine, the BP is increasing. So after medicine, BP more. Before medicine, BP less. So mu1 is less than mu2, left tail test. Medicine will increase the BP. Level of significance alpha 0.05 given. Degree of freedom n-1, 9 minus 1, 8. 9 patients data is given. The test is statistic. We apply paired t-test since increase in BP difference is given before medicine and after giving the medicine. Here, how much was the BP before giving medicine and how much was the BP after giving medicine not given. But simply difference is given. Difference is given. So we apply paired t-test to apply the to find out whether applying the medicine will increase the BP or not. So here D. D stands for difference in BP readings. In BP readings before giving medicine and after giving. So here D. 8, 3, minus 1, 4. These are the values given. Square it. 8, 8 is a 64, 3, 3 is a 9, minus 1 square 1, 4, 4 is a 16, 3, 3 is a 9 like that. So summation D 20, summation D square 204. Now we apply the formula. T is equal to D bar. Previous video I have completed paired t-test. In paired t-test, the t value is D bar divided by S square by N under root. S square is 1 by N minus 1. Summation D square minus summation D whole square by N. So N. N is how much? 9. N is 9. So 9 minus 1 is 8. Summation D square 204. Summation D 20 whole square by N. So S square you will get 19.945. D bar is summation D by N. 20 by 9 you will get 2.22. Substitute you will get T value 1.49. So positive 1.49 is the computed value of T. Now table value of T at 5% level for V is equal to 8 for left tail test is minus. Because we are having left tail test, so minus computed value will be minus 1.86. Now decision. The computed value of T 1.49 is greater than the table value minus 1.86. So it falls in acceptance region. Minus rejection region will be only on the left side. You can see the diagram here. The rejection region, critical region is this one. This is T minus 1.86. This whole region is acceptance region. Now our computed value is 1.49. 1.49 will lie here. Positive 1.49 will lie there. So it falls in acceptance region. So null hypothesis is accepted. There is no increase in BP. There is no increase in BP by administering the medicine. That's it. So this is the end of the 18th problem. So far 18 problems I have completed. That means in between 2 problems are left. That is 14th and 17th problem. Only 2 problems are left. Those problems are paired t-test. Inshallah, we'll continue that in the next video.